5.3 trigonometric function of angles here S. Okay, so last time I started talking about this section, and I evaluate some trigonometric function at any angle. So the basic important two things. Number one is here. Number one, we need the sine of the trigonometric angle, trigonometric function, I mean. The sign, I mean, positive or negative. Number two is the reference angle. So the two important things to find the value or to evaluate the trigonometric function at any angle, we need the sine and we need the reference. The sine here, like I said last time, so the angle, it depending in the angle in which a quadratic. So for the first quadratic, all functions like the sine, cosine, the tan, all of them are positive. For the second quadratic, the only function is positive is the sine function. For the third quadrant, the only function is the tan function, tan of the angle. And here is the cosine function. I said you can remember all of them as all student take calculus, all student take calculus. So this is for the sine of the function. But about the reference for the function, I said it is like acute angle between the x-axis and the terminal side. So I define the second one as acute angle between, this is number two, it is acute angle between the terminal side and the reference angle. So here is acute angle formed by the terminal side and the x-axis. Acute angle formed by the terminal side and the x-axis. And I gave a lot of examples last time. Today we're going over the identities. So first identity is the fundamental identities. So reciprocal identity. Here we have the reciprocal identities. So fundamental, sorry, numbers two. Fundamental identities. So first identity is the reciprocal identity, called the reciprocal. So the reciprocal identity, first one is here. So here we have to know the cosecant. Daniel, can you go back? Yes, here. So here we have two things to evaluate any angle. We need the sine and we need the reference. The sine is come from the quadrant for the angle, all sine, tan, cosine, and here for the reference angle, acute angle formed by the terminal side and the x-axis. Now we have some fundamental. First of all, for the first one is the reciprocal identity. So we have the cosecant theta is the reciprocal of 1 over sine theta. Second one is the secant of the theta is the reciprocal of the cosine function, 1 over cosine. The third one is the tan. The tan function is equal sine over cosine. Sine theta over cosine theta. And the last one is the cotan. Theta is the reciprocal of the tan, 1 over tan function. 1 over tan theta. And also here 1 over tan is the reciprocal of the tan. I can say it's equal cosine over sine. Cotan theta also equal cosine over sine because it's the reciprocal of the tan function. So I can say the cosine theta over the sine theta, like this. So this is all of them, 1, 2, 3, 4, 5. All of them are the reciprocal identity. The second identity is called the Pythagorean identity. Here. Identity. So for the Pythagorean identity, we have 3 identities for this. Number one is the sine square of the angle plus the cosine square of the angle always equal 1. Number 1, 2. If I divide everything here by the cosine square, I will get sine square theta over cosine square theta. I will get tan square theta plus 1 equal 1 over cosine square is the reciprocal of the secant square. So I will get here secant square theta. Number 3, if I divide all this identity by the sine square, I will get sine square over sine square, I will get 1 plus cosine square over sine square is the reciprocal of cotan square, the reciprocal of the tan, I mean, square. It is cotan square theta. And here 1 over sine square is cosecant square. The reciprocal of sine square is cosecant square theta. So all of them, number 1, 2, 3, all of them called the Pythagorean identities. You should to memorize all of them. Okay, now I'll give you some example. This example is very important. You should to focus to this kind of example. So the example is evaluate trigonometric function if here we have some condition. If the tan theta equal 2 over 3, and this theta, it's in the quadrant 3, and theta, the location for this angle, it is in the quadrant 3, in quadrant 3, like this, in the third quadrant. The question is find cosine theta, like this. Find cosine theta. Okay. Evaluate a trigonometric function if the tan of the angle is 2/3, and this angle, it is in the quadrant 3. Find cosine theta. So first of all, when you see something like this, question like this, you have to graph a right triangle like this, and then you have to use the tan of the angle theta. You must use the angle of theta. This is a right triangle, and by this right triangle, you have to use the tan of theta. So as I know before, the tan of theta, what's equal? Tan of theta. What is that equal? The opposite over what? Adjacent, exactly. Edge. And this is equal to over 3. How I know? From here. So this is my angle, theta. The opposite of theta is 2. So this is the opposite side. From this point to this point, this is my opposite side, this 2. And the adjacent is 3. From this side to this side is the adjacent. So this is 3. You should to find the value of the hypotenuse here, x, to find the cosine angle, the cosine of theta. Okay, so now to find the value of x, you should to use the Pythagorean theorem. Pythagorean theorem said 2 square, this side, the opposite of the theta square, plus the adjacent of the theta square equal the hypotenuse square. So 2 square, now by using the Pythagorean theorem, Pythagorean theorem, okay. Okay, by using the Pythagorean theorem, 2 square, 2 square plus 3 square equal the hypotenuse square, x square. I'm looking for the value of x. Now 2 square is 4 plus 3 square is 9 equal x square. So actually x square equal 4 plus 9 is 13. So x square equal 13. So the value of x, we have to take the square root for both sides. X equal what? Square root of 13. Again, Pythagorean theorem said the opposite side of the angle square plus the adjacent square equal the hypotenuse square. So 2 square plus 3 square equal x square. 2 square is 4 and 3 square is 9. X raised to the power 2 is x square. 4 plus 9 is 13. So x square equal 13. Can we leave it as x square equal 13? No, you have to find the value of x. The value of x, you have to take the square root for both sides. Square root of both sides, you will get x equal square root of 13. So here x equal the square root of 13. Now, you go back to the question. The question told you this angle has a location in the quadrant 3. Quadrant 3, this is mean if you want to graph a small graph like this is my Cartesian plane. My initial side, it is always the positive x-axis. My initial side, like I said before, always the positive x-axis. And because theta it's in the quadrant 3, so my terminal side must be in the terminal 3 like this. So the angle should be something like this. This is my angle. This is my theta. It's in the quadrant 3. In quadrant 3, the sign for the cosine function is, as we know here, all sine, tan, cosine. The only one here is positive is the tan function. So what's the sign of the cosine function in the third quadrant? Is it positive or negative?
Is it negative?
Negative, only negative.
Yeah.
The cosine function will be positive only in the fourth quadrant. And also the reciprocal of the cosine function in the fourth quadrant will be positive. In the third quadrant, the tan function is the positive function, and also the reciprocal of the tan is the cotan will be positive, and everything else will be negative. So go back to the question. So here the question told you find the cosine of the for the angle. So because the angle it's in the third quadrant, the sign should be negative. This is the first step. And to find the cosine of the angle, the cosine of the theta is the adjacent over the hypotenuse. Edge over hypotenuse. So this is equal negative. Adjacent is 3. Negative 3 over the square root of 13. And this is my answer. So this is the answer for my question. Yes. No, we can keep the answer like this. If you wanna like multiply the both side by the square root of 13, will be like, also it's like you can simplify this and more if you want, or you can leave the question like the answer like this. It is fine. So you can like also write the question, the answer as cosine of theta equal the minus 3 over square root of 13. You can multiply the both side by square root of 13 like this, square root of 13. So you get answer as 13. Whatever you need, it is fine. And you can keep like the answer like this, 3 over the square root of 13. Any question for this example?
Yeah, I have a question on how did you put the line like into the quadrant? Like why is it negative? Like
Why
why
it's
is the
negative?
line in the third quadrant?
Why it's negative?
Yeah.
Okay. So in the third, because here they told me that theta is in the quadrant 3.
Oh,
The quadrant 3 means the cosine function is negative. That's why I put the negative. The
okay.
only
So isn't that the one with the tan? Like all
yeah,
students take so the tan is the one that's negative?
if the question, the tan will be positive. In the third quadrant, if the question find the tan of theta, the tan will be positive, because the tan, as we see here, the tan function here is positive. The only function here is positive is the tan. But the cosine angle, it is negative here. The sine angle will be negative. The only positive is the tan, and also the reciprocal of tan. The reciprocal of tan is cotan. The tan and the cotan, the only both function here are positive.
Okay.
That's why we put the negative here for the cosine.
Okay, thank you.
You're welcome. Another example. So we have another example similar to this. Find if the secant theta equal to, and this theta, this angle in quadrant A4. The question is find the 5 trigonometric functions of this angle theta. Okay, so first of all, we have the secant of theta equal to. Second things, we know where is the location of this angle. The angle, it's in the 4th quadrant. Now, the secant theta equal to, right? The secant theta, it's the reciprocal of which function? Do you know which function? By using the identities here. It is the reciprocal of the cosine function. The reciprocal of cosine. So this is mean secant theta equal to the cosine of theta equal what? The reciprocal of 2, 1 over 2, 1/2. Again, the secant theta equal to the cosine theta, it's the reciprocal of 2, 1 over 2. Because there is a relation between secant and cosecant. The secant is the reciprocal of cosine, and the cosine is the reciprocal of secant. Okay. Now, we know the location of the angle. The angle, it's in the quadrant 4. So let me graph small. First of all, let me graph the right triangle like this. This is my right triangle. And this right triangle, I have the angle here, theta. This is theta. The cosine function equal the adjacent over what? Hypotenuse. Correct. The adjacent is 1. So this is from here to here. The value is 1. And also the hypotenuse is 2. So from here to here, the value is 2. Now we have unknown is x. We can find the value of x again by using the Pythagorean theorem. The Pythagorean theorem said 1 square plus x square equal 2 square. Then 1 square plus x square equal 2 square. 1 square is 1 plus x square equal 4. I need to find the value of x square, so I have to subtract both sides by 1. I will get x square equal what? 3. Now take the reciprocal of both of them. Take the square root, for both of them.
It'll be x equals square root of 3.
Exactly. This is the value of x. So x equals the square root of 3. Again, 1 square plus x square equal 2 square. The 1 square is 1 plus x square equal 4. we need to find the value of x only. We have to subtract 1 for both sides. So this is cancelled out. I will get x squared equal 3. Take the radical for both sides. X equals square root of 3. Now I find the value of x. I can find that. Now let me graph also the Cartesian plane like this. Here's the Cartesian plane again. Like I said, the initial side must be the positive x-axis. And my terminal side, it is in the fourth quadrant like this. So the angle should be something like this. This is theta. Okay. So first of all, the only function will be positive in the fourth quadrant. It is the cosine function. The cosine function and the reciprocal of cosine is the only function will be positive. So the cosine of theta equal the adjacent over the hypotenuse 1 over 2 and is positive. Now the secant theta is the reciprocal of this. It is positive 2. Now the sine function of theta is the opposite over the hypotenuse, but don't forget the minus. Minus because it is in the third quadrant, in the fourth quadrant, I mean. Fourth quadrant, the function sine would be negative. So the square root of 2 of 3 over 2. Cosecant is the reciprocal of sine. It is negative 2 over square root of 3. The tan function. The tan will be negative again. It is the opposite over hypotenuse, opposite over the adjacent. Square root of 3 over 1. And it is equal the minus square root of 3. The cotan theta, it's the reciprocal of tan minus 1 over square root of 3. So this is all the trigonometric functions of theta. Any question? Six trigonometric functions. Any question for this? Is it clear? Yes, we have to find all of trigonometric functions when they ask for all of them. Cosine, secant, sine, cosecant, tan, cotan. And the important things again is the sign. Positive, positive, negative, negative. And here we have negative, here we have negative. Don't forget the sign. Sign is very, very important. Now, we're going over the area, the last things in this section of triangles. Area of triangles. So I'm going to give you the formula for the area for any triangle. So we have to know the area. The area script A like this of triangle with length A and B with include angle. The angle is theta. Is defined as script A, the area equal 1/2 times A times B times the sine of theta. This is the formula for any triangle, for the area for any triangle. So easy example for this, find the area for triangle. So the triangle look like this. It is not a right triangle. Here we have 10 centimeter. Here we have 3 centimeter. And the angle between these two sides is 120. The question, find the area for this one. So as I know the definition of the formula for the area, it's equal 1/2 times A. The first side is 10 centimeter. 10 times the second one, the length is 3 times the sine of the angle. The angle is 120. So before we solve these things, we have to find the sine of 120. So first of all, sine of 120, the angle 120, we should to know what is the location for this angle. So here is my Cartesian plane. So my initial side is always the positive x-axis like this. This is my initial side. Now 120, as we know before, this angle from here to here is 90 degree. So this is here, it's 90 degree. And this angle here, if you start from this point to this point, is 180 degree. So 120 is between 90 degree and 180 degree. So it's supposed to be here. Okay. So actually, the angle, it is in the second quadrant. The angle, it is in the second quadrant. So the sine in the second quadrant has positive sign. Has a positive sign. Why? Go back here. All function, the sine function is positive, the tan, the cosine. So in the second quadrant, the sine function must be positive. So sine 120 is a positive. Now, we should to know what's the reference angle. What is the reference angle? The reference angle is a acute angle between the terminal side, this is my terminal side, and the x-axis. Here's my x-axis. So this is my acute angle. So what's the value of my acute angle? Is 60, correct? How do you know? The angle from this point, actually the angle from this point to this point is 120. And here we have 180. So the acute angle, the reference angle I mean, it is 180 minus 120. And this is equal what? 60 degree. So my reference angle is 60, correct. So now I can find the value of the sine 120. So the sine of 120 equal the positive, like this, sine of the reference angle. The reference angle is 60. So this is equal positive. The sine of 60, you have to go back to the table. You have to memorize the table. You have to memorize the table. What is the sine of 60? What's the sine of 60 from the table? The square root of 3 over 2. Now we go back to find instead of the sine 120. So the area equal exactly the square root of 3 over 2. This is correct here. Now we go back to the area. The area equal 1/2 times 10 times 3. 1/2 times 10 times 3 times square root of 3 over 2. So the script A, the area, equal 10 times 3, 30 over 4. It's 40. Ten times 3 is 30. Over 2 is 15 times square root of 3 over 2. And this is the final answer. Any question? Yes. Can go back here. No questions. So again, this is the reference angle, and this is the angle. Okay, this is what you should to know about this section. Now let's go to the 5.4, the inverse function. Five point four inverse trigonometric functions and right triangle. Okay. Inverse trigonometric functions and right triangle. So first of all, we're going to do the inverse for the sine, inverse for the cosine, and the inverse for the tan functions. So we should to know if my function look like this, sine x, this is equal y, suppose this is equal y, you should to know we're going to, because we know the sine function is not one-to-one function, we have to restrict the domain. when we restrict the domain for the function sine function, so we can find the inverse for the function. We can find the inverse for the sine. So first of all, you should to know if we want to do the inverse for both sides. If you want to do the inverse for the sine function and the inverse for the y, take the inverse sine for both sides, you will get x equal, you will get sine inverse of this value y equal x. And the same things for the cosine. If I have cosine x equal y, take the inverse for both sides, and this will give me the cosine inverse of this y equal x. And same things for the tan. The tan function x equal y. If you want to take the inverse for both sides, you will get tan of y, tan inverse of y equal x. So I'm going to give you like easy and simple example before we start for this section. So the example, is, so we know the sine of pi over 6. What is the sine of pi over 6? What's the sine of pi over 6? Pi over 6, actually, it is the 30 degree. What's the sine of 30? Anyone can tell me what is the sine of 30? So the sine of pi over 6 is the same as the sine of 30, and the sine of 30 is 1/2. It is 1/2, 1/2. If you're taking the inverse for both sides, you will get sine of 1/2, sine inverse of 1/2 is the same as pi over 6. And the same things for the cosine. Cosine of pi over 3. What's the cosine of pi over 3? Pi over 3, actually, it's the 60 degree. What's the cosine of 60? The cosine of 60.
Square root of 3.
Yes, square root of 3 over what? Over 2. Square root of 3 over 2. This is the cosine of pi over 3. Now, if you're taking the inverse for both sides, you will get cosine inverse of square root of 3 over 2 equal pi over 3. Now we're going to give you what exactly I restrict for the domain and the range for these functions. This is just like the general idea for this section. Now I'm going to give you a table, show you what's the domain and the range such that I restricted to make this function has inverse. So first of all, you should know here is the function. It is 1/2 here. The cosine pi over 3, is it what 1/2? Cosine of 60, yes.
Yes, the cosine of pi over 3 is 1/2.
Okay. So the cosine of 60 is 1/2, is 1/2. So the same things, cosine inverse for 1/2 is 1/3. Thank you. So cosine inverse for this, they give you the angle, y/3. Have you finished, Sandra? So first of all, you have to know here, I'm going to give you a table. This table is very important, the function. Here the domain, and here is the range. First function is the sine function. I mean, like the sine inverse, sine inverse function. Here the cosine inverse, and here is the tan inverse. So we should to know, we have to restrict the domain for the sine. So the new domain for the sine function, the domain for the sine function, and also the range for the sine, the domain for the sine inverse, it's supposed to be from -1, 1. And the range must be from -π/2 to the angle π/2. For the cosine inverse, the domain must be from -1 to 1. And the range is from 0 to π. And here the tan inverse must be, the domain is all real numbers, and the range is from -π/2, π/2, but it is different about the sine inverse, such that the end point here are including, but here the end point, the π/2, the -π/2 and π/2 not including. So the example comes for this like this. Look, example. The question is, evaluate the inverse trigonometric functions for so number 1 is sine inverse of the function square root of 3/2. The question like this: evaluate the inverse trigonometric function for the sine inverse of square root of 3/2. So first of all, to solve something like this, you have to ask yourself, is the square root of 3/2 is in the domain? The domain of the sine inverse is at the between -1 and 1. So you have to ask yourself, is the square root of 3/2 belong to the interval from -1 to 1? What's the answer? Is yes or no? Is this value square root of 3/2 belong to the value, the interval -1 to 1? You should to know here the square root of 3/2 is like close to 1/2. This value is close to 1/2. Is the 1/2 belong to this interval from -1 to 1? Is the 1/2 belong to the interval from -1 to 1? So this is my real line to show you exactly. This is from -1 here, this is -1, and this value is 1. And here we have what? 0. So here we have minus 1/2, for example, -1/4, -1/3, and here we have 1, and the -1/2, we have 1/4, 1/3, and like all these numbers. Is square root of 3/2, like this number is close to 1/2? Is it is it between -1 to 1? The answer is yes, correct. The answer is yes. So if the answer is yes, I can find the value of the sine inverse. So this is the first step you have to check. Because the answer is yes, I can find the value of the sine inverse. Now, second step, this is the first step. Second step, you have to write down like this, sine inverse of the square root of 3/2 equal y. And in the same things, sine of y equal the square root of 3/2. What's the value if I plug it inside the sine? They will give me square root of 3/2. This y must belong to the range. Look at the range. Again, sine inverse of the square root of 3 should equal y. This is the same as sine of y equal the square root of 3/2. And this y must belong to the range. The range here is the -π/2 to the π/2. I will show you exactly what does that mean here. This is my Cartesian plane. The angle must be like this. This is the -π/2, and this is the π/2. Okay? So my question is, what is the value of y here, such that if I plug it inside the sine function, they will give me square root of 3/2. What's the value here if I plug it here? They will give me the square root of 3/2. You have to go back to the table that I give it to you last class for section 5.2. What angle, if I plug it here, they give me the square root of 3/2? What is it? Is it 30? Sine of 30, they will not give me square root of 3/2. Sine of 30, they will give me 1/2. Is it 45? Sine of 45, they will give me the square root of 2/2. So not the answer. Is it 60? Sine of 60, they will give me the square root of 3/2. Yes, so the y is actually 60 degree. But here the answer should be in radian. So when you convert the 60 to the radian, will be the pi over what? Over 3. How do I know this? You should to multiply the 60. How to convert that? 60 multiplied by pi over 180. and this is equal 60 over 180 times pi. You can reduce the 0 with the 0 and the 6 with 18. You will get pi over what? Over 3. So the angle here should be 60 or pi over 3. So the answer is y equal pi over 3. Okay, I will give you another example. Same technique. Find cosine inverse of minus 1/2. So first of all, you should to check the minus 1/2. Is the minus 1/2 belong to the domain? What is the domain of the cosine? The domain of the cosine inverse must be from -1 to 1. Is this number is belonging to the value from -1 to 1? Is the minus 1/2 belong to this interval from -1 to 1? The answer is yes. Correct. The answer is yes. The minus 1/2 is belong to this interval. So because the answer is yes, so we have a value here. We have a value. We have answer. So we're going to use the same step like before. Cosine inverse of minus 1/2 equal y. Now take the cosine for both sides. You will get cosine of y equal minus 1/2. This y must belong to the range of this angle. What's the range? Range, go back to the angle from 0 to pi. The range must be from 0 to pi. So I mean from 0 to pi, if I want to write graph the Cartesian plane again, I mean from 0 to pi, the angle should be like this. This is 0 and this is pi. This is 0 and this is pi. This is the angle y must belong from 0 to pi. Okay, so what's the value of y? If I plug it inside the cosine, they will give me 1/2, minus 1/2. Because the cosine here, they give me minus. This is mean the angle must be in the second quadrant, right? Because the cosine here, the answer is minus 1/2. This is mean the angle should be from in the second quadrant here, this quadrant. The angle must be from here to here. Why? Because the answer for the cosine is negative 1/2. As I said in the previous section, when the cosine is like when the cosine should be negative in the should be positive only in the first quadrant and also in the fourth quadrant. But because the angle it's from 0 to pi, so the angle here must be from this point to this point. Now, so you're supposed to hide the minus. What angle, if I plug it inside the function cosine, so here I am going to hide the minus. What angle, if I plug it inside the cosine, they will give me 1/2. Let me check. Cosine of 30, the answer is the square root of 3 over 2. It's not the answer. Cosine of 45 is the square root of 2 over 2 is not the answer. The cosine of 60 is 1/2. So correct. So here, the y reference is 60. So again, go back to the table I gave it to you in last class. What's the angle in the second quadrant has reference 60? What's the angle in the second quadrant has reference 60? Because here all our work, it is radian, so I'm going to convert the 60 to pi over 3. So the y here, y reference is pi over 3. What is the value of y such that has a y reference pi over 3? It is in the second quadrant from the table last time. You should to memorize all the tables from last time. So I'm going to give it to you this time. So the reference angle is pi over 3. It is in the, because the angle it's in the second quadrant. The second quadrant should be 2 pi over 3. So the value of y here must be 2 pi over 3. So the answer is 2 pi over 3. Okay, another example. Find tan inverse of 1. How do you know the sine of 60 is the square root of 3 over 2? You should to memorize the table. I'm going to check if the table is still in my screen, so I'm going to show you how I know these values. Yes, here you go. For the student, they ask me about the table. Here is the table. Can you see the table? You should to know. All students should see the table. Okay. You should to know the sine of 0 is always 0. This table, you should to memorize it. You cannot use it in the exam. The important angles we're going to use it a lot is 30, 45, 60. Sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. The tan of 30 is the square root of 3 over 3. 45. The sine of 45 is square root of 2 over 2. The cosine of 45 is square root of 2 over 2. The tan of 45 is 1. For the angle 60, the sine of 60 is square root of 3 over 2. The cosine of 60 is 1/2. And the tan of 60 is square root of 3. And the same things for the cosecant, the secant, the cotan, because all of them are the reciprocal, like we said last time. Is it clear? This table, you should to memorize it to find or to know or to continue for the section 5.4. They will help you a lot. You cannot use this table in the exam. You have to memorize this table. And also, you not just memorize it for the degree. You should to memorize it also for the radian. you have to know the 30 degree is pi over 6 in radian, and the 45 degree, it is pi over 4 in the radian, and the 64 degree, it is pi over 3 in the radian. Is it clear? Okay, I'm going to go back to the class. Now my question is find tan inverse of 1. The same idea. We should to ask yourself, is the 1 belong to the R, to the real numbers? The answer is yes. The 1 is the real numbers, is belong to the real numbers. Why? Because the domain here for the tan inverse is the real numbers. Is the 1 belong to the real numbers? The answer is yes. Second question, tan inverse of 1 equal y. Take the tan for both sides. So tan of y equal 1. Now my question is, y here, the y here must belong to the range. The range of the tan is from minus pi over 2 and pi over 2. So my question, which angle, if I plug it here, they will give me 1. What angle, if I plug it here from the table I showed you just 2 minutes ago, they will give me 1. $45, correct. Muhammad said 45. So the y equal 45 degree. But the answer here must be in radian. So 45 degree, if you want to convert it to the radian,
Pi
it
over
is
4.
pi over 4, correct. So the answer y is must be pi over 4. And pi over 4 is belonging to the range of the angle. The range, let me show you again. Here's my Cartesian plane. The range, it is from minus pi over 2. This is the minus pi over 2 to pi over 2. This is the pi over 2. So the answer is pi over 4 because the pi over 4, it is between minus pi over 2 and pi over 2. Any question? Is it clear? Okay. So another things, the example. Find the angle. Yes, here you go. You're welcome. So find the angle. Here, find the angle theta. This angle is theta. In the triangle shown in the picture. So my picture, like it is a triangle like this. It is a right triangle like this. And the question is find the angle. This my angle find this angle such that they give you here the value is the square root of 3. The opposite side is the square root of 3, and the hypotenuse for this angle is 2. So I'm going to use the ratio, the trigonometric ratios or the trigonometric function to find the value of this theta. So the best things I can use for this theta, because I know the opposite over the hypotenuse is given. So the opposite over the hypotenuse is the sine function. So the sine function, as I know, it is the opposite over hypotenuse. So the opposite is the square root of 3 over 2. Hypotenuse is 2. Now I can find the value of theta by using the inverse function, right? So by using the inverse function, this section is the inverse. So by using the inverse, I can find the value of this theta. So take the theta for like the inverse for both sides. When you take the inverse for both sides, I will get here sine inverse of this over sine inverse of this value. So sine inverse for sine of theta, they will give me theta equal because the sine inverse with the sine they cancel out. So here it's now my question is the square root of 3 over 2 belong to the domain of the sine inverse? What's the domain of the sine inverse? The domain of the sine inverse is between -1 and 1. The interval from -1 to 1. So is the square root of 3 over 2 belong to the interval from -1 to 1? This is my question. What's the answer? Yes. The answer is correct, yes. The answer is yes. Because the answer is yes, so I can find the value of theta. The theta has a value. So theta has value. So this is me, you have to go back to the red one here. What's this? So here, the red one is sine theta equal the square root of 3 over 2. You should to ask yourself, what's the value of theta if I plug it here? They will give me the square root of 3 over 2. From the table, I just show you the table, the blue table, I mean. What's the value of theta if I plug it inside this function, the sine function? They will give me the square root of 3 over 2. Is it theory? If I plug here the 30 degree, the sine of theory equal 1/2, right? So the angle is not theory. Is it 45? The sine of 45 is the square root of 2 over 2. So it's not the answer. So is it 60? Sine of 60 is the square root of 3 over 2. So the answer is 60. So theta here equals 60 degree, or you can say is the pi over 3. Pi over 3 is 60 degree. So the value here of theta is pi over 3. Any question? Okay, if no questions, I'm going to give you another example. So the example like this. Find cosine of a sine inverse. Now we have two functions. Cosine of sine inverse of 3/5. Find the cosine of sine inverse of 3/5. Okay, to solve question like this, you have to suppose everything here inside the cosine is theta. So let theta equal what? Sine inverse of 3/5. Then we have to solve this. First of all, you have to take the sine for both sides. When you take the sine for both sides, you will get what? Take the sine for both sides. Sine of this, sine of this. You will get sine of theta equal 3/5. Why? Because sine, they cancel the sine inverse. Sine of theta equal 3/5. What do you know about the sine? Is it the opposite over what? Over the hypotenuse. Opposite over the hypotenuse, correct. So let me graph, like if you want to graph a right triangle. Now you will graph a right triangle like this. This angle is theta. The opposite is 3. And the hypotenuse is 5. Now you should to find the value of x here. If you find the value of x, you can use this triangle to find the cosine of this angle of theta. How can I find the value of x? This is review. By which theorem I can use the value to find the value of x? By Pythagorean theorem. Then by using Pythagorean theorem, they help me to find the value of x. 3 square plus x square equal what? The hypotenuse square, 5 square. 3 square is 9 plus x square equal 25. Now to find the value of x square, we have to subtract the 9 for both sides. Subtract the 9 for both sides. This will cancel out. So I will get x square equal what? 25 minus 9. What is the answer? What is 25 minus 9? Is 16, correct. Now take the square root of take the square root of 16. X, what's the value of X? Is 4, correct. So the value of X here equal 4. Now it's easy to find the cosine of this angle. What's the cosine of this angle? The cosine of this angle is the same as the cosine of the sine inverse of 3 over 5. The cosine is 4 over 5, exactly. Adjacent over the hypotenuse is 4 over 5, and this is my answer for this example. So the cosine of sine inverse of 3 over 5 is the same as the cosine of theta is 4 over 5. Any question for this example? Any question for this example? Anyone has a question or? No questions? So we finished this section. The last things we left, the last section for this book is 10.1. Is very easy section. I'm going to give you like the introduction for this section, and next time I'm going to finish it. So the last section is 10.1 is system of linear equation in two variables. Okay. System of linear equation in two variables. So suppose I have like the system. What is the meaning of system? So the system of linear equation and their equations. I mean, like for this, if I have the two linear equation, the first one is 2x minus y equal 5. This is the first equation. And my second equation is x plus 4y equal 7. This is my second equation. So this is equation 1. And this is equation number 2. So we have like three kinds to solve this system. The first one is by using the substitute method. We have three methods. The first method is the substitution method. So what does that mean? So we have some steps for this method. The first step, we have like three steps for this method. The first one is solve for one variable in terms of the other variable. Second step is substitute Third step is back and substitute. This is the steps. Yes, Layla, correct. So I'm going to solve, for example, the system 2x minus y equal 5 and x plus 4y equal 7 by using the substitution method. First of all, we have to solve for one variable in terms of the other. So we have, if I have two equations, the first equation is my 2x minus y equal 5. This is the first one, equation 1. And equation 2 is x plus 4y equals 7. This is equation number 2. So the step number 1, solve for one variable in terms of the other. So I'm going to catch equation number 1 and I will solve it in terms of the other one. So here for step number 1, my equation 1 is 2x minus y equal 5. Aisha said y equal minus 5 plus 2x. This is correct. If here, I will move this one to this side, and in the same time, I will move the 5 to this side. So to moving the y to this side, I have to add y for both sides. To move the 5 to this side, I have to subtract the 5 for both sides. So I will get y equal x 2x minus 5. Again, moving this to this side, I have to add y. Moving this to this side, the green one, we'll have to subtract the 5. So this is the first step. Second step, I have to substitute. I have to substitute this. This is equation number 3. I have to substitute this in equation number 2. So let me substitute this in equation number 2. So equation number 2 said x plus what? X plus 4y equals 7. This is equation number 2. I want to substitute equation number 3 inside number 2. So I will get x plus 4. Now equation number 3 is 2x minus 5. 2x minus 5 equal 7. Okay, distribute the 4 inside the parentheses. I will get x plus what? 8x minus 20 equal 7. Exactly. Now 8x plus x is 9x minus 20 equal 7. I can move this one to this side, right? Exactly. So I get 9x equal 7 plus 20. Now I can get here 9x equal what? 27. Divide both sides by 9. X what equal? 3, correct. This is the first value of x. Now I have to find the value of y by back and substitute again. So step number 3. This is step number 1. This is step number 2 here. Now step number 3. So x equal what? 3. X equal 3. Now I will choose one of them to plug the 3 to find the value of y. I will use the first one. Is easy, right? 2x minus y equal 5. 2x minus y equal what? 5. Again, 2x minus y equal 5. Okay, plug the 3 inside this equation. You will get 2 times 3. So 2 times 3 minus y equal 5. 2 times 3 is 6 minus y equal 5. You can move this one by adding y for both sides. Add y for both sides. You will get 5 equal, 6 equal 5 plus y. Now subtract the 5 from both sides, minus 5 for both sides. You will get 6 minus 5 equal what? Y. So what's the value of y? Is 1. So x equal 3 and y equal 1. And this is the answer for, this is the first method, the substitution method, the first method we learned for this class. Next time, I'm going to give you another 2 methods. We can solve the linear system of 2 variables. Okay, so I will see you next, I will see you Tuesday, and it will be the last lecture for this semester. Have a good day, everyone.